We are back to talking about cars in the context of transport, but now mostly on hybrid cars, even though I'll show some broader data. So this is ranked at number 49 with 4 gigatons of CO2 to be reduced by 2050. Net cost is actually a gain of $598.7 billion, so negative net cost, and net savings are $1.76 trillion in terms of displaced gasoline and of course other co-benefits that we always mention in terms of air quality, noise, and health, and so on and so forth. We mentioned the first electric vehicle, Ford, Edison, and then Porsche, who had built something in 1897, I think. He had put in a motor that was directly driving the wheels, and then also had a combustion engine which would kick in when the battery ran out. So it was a pretty amazing design at that time. And now the modern designs like this Chevrolet Volt concept is highly advanced plug-in electric hybrid. However, the 1-liter 3-cylinder turbocharged motor never powers the wheels directly. Instead, the Volt uses combustion engine which runs at a constant speed to maximize efficiency. You cannot gear it up and down. Generates electricity to power the electric motor and charge the lithium-ion battery. So it's a kind of a unique design. The end result is a capacity to travel 60 miles on just 0.4 gallons of gas, averaging an astonishing 150 miles per gallon. So that's a really well-built American electric hybrid car. So pretty amazing battery hybrid car. Just to remind ourselves, let's look at motor vehicle ownership again per 1,000 inhabitants in 2014. As I mentioned before, economically growing countries like China and India are something to be watched for, because rich countries have more than 2 cars per family, whereas these are still at a relatively low number, less than 100 or so per 1,000 inhabitants. China has made a lot of progress on electric scooters, electric bicycles, electric cars, and so on, but India is still to catch up, even though it has great plans for going all electric on vehicles. So those economically growing countries obviously can leapfrog some of the methodologies or approaches that the rich countries used in terms of sticking to bigger and internal combustion engines, not worrying always too much about fuel efficiency, even though now CAFEs or fuel efficiency standards are quite standard across the world. California, for example, has some of the strictest fuel efficiency standards. They negotiated a special treaty with the federal government to set their own standards based on the massive smog problem they had way back in the 1940s and 50s. So this is the sales again of the various battery electric vehicles, plug-in hybrid electric vehicles. Before I kind of screwed up on LCVs. LCVs are light commercial vehicles, and LDVs are light duty vehicles, which are more like trucks. So the LCVs are more like little buses and passenger vehicles. Okay, so anyway, here are the numbers. Again, China dominates battery vehicle, plug-in hybrid, and what else? Sometimes there is also fuel cell electric vehicles included in them. So you see there has been a substantial number of millions of cars sold has gone up, but the total market share remains still remarkably low, which has to grow. And this is the electric mobility data from Statista, which I picked up from the International Energy Agency, I think, or World Economic Forum, I forgot. So Norway is up here at 49.14% of all new passenger cars sold in 2018. Iceland is right behind, and then you have the various other countries. China is down here at 4.44%. So even though absolute number is much high because the population is much higher, in terms of percentages of new passenger car sales, Norway is way ahead. So top 3 markets in total electric vehicle sales in 2018. You can see that in absolute numbers, China is up here more than 1 million. US is not bad at 361, but still people are buying bigger cars and SUVs and so on, especially when the gas prices drop. Norway 73,000, but their percentage is almost 50%. So for a small country, that's pretty amazing. But we also have to keep other factors in mind. So if you imagine the global electric vehicle stock in the stated policy scenarios at present, going from 2090 to 2030, number of millions of vehicles to be sold here by 2030 include plug-in light-duty vehicles, light commercial vehicles, trucks, buses, and so on. And if you look at the sustainable development scenarios, then obviously this number needs to bump up quite a bit to almost 250 million vehicles by 2030, with the plug-in light-duty vehicles leading because they are bigger gas guzzlers than the cars and hybrid cars and light commercial vehicles and so on. Okay, the other thing we have to worry about is how they are going to be charged, right? It's all great that we got battery vehicles and electric vehicles, but the electricity demand has to be kept in mind from the electric vehicle fleet by country and by region. So looking at United States, China, Europe, Japan, India, and rest of the world, you expect electricity demand to go up in terms of terawatt hours by 2030. And in the stated policy scenario, it's low, but because we demand more electric vehicles, it's going to be higher in the sustainable development scenario. This is from the International Energy Agency, which means the source of electricity is going to be very critical as well. At the same time that we are increasing electric vehicles, we have to reduce the coal for producing electricity. And the other thing to worry about is the batteries. So annual cobalt demand for electric vehicle batteries is expected to go up as well, even though there is a large uncertainty in the estimates. So again, stated policy scenarios and sustainable development scenarios. And lithium demand for electric vehicle batteries. So already there are talks about where the lithium is going to come from, when it's going to run out, issues associated with mining for these materials for electric vehicles and so on. So life cycle analysis is what tends to take care of end-to-end accounting of all the carbon involved and so on and so forth. So one has to be really careful that it's not as easy as saying buy electrical and we are done with it. So overall, under some business as usual scenario projections, 23 million hybrid vehicles will be in operation in 2050, less than 1% of the car market. So that's still remarkably low. We estimate growth in 2050 to reach 6% of the market, or 315 million hybrid vehicles. These additional 315 million cars can reduce carbon dioxide emissions by 4 gigatons by 2050, saving car owners 568 billion in fuel and operating costs over 3 decades. So the hybrid focus here is again to deal with the so-called range anxiety, where people are just not getting comfortable driving just electric or battery vehicles. They demand some reliance on internal combustion fossil fuel, but as we saw with Chevy Volt, that can be managed in terms of how the engine is run and what it is actually used for. Otherwise, internal combustion engines are remarkably inefficient. More than 90% of the energy is just wasted. several thousand pounds of material is being moved by the car to move a passenger often who is just about 150 or 200 pounds or less. So it's a remarkable waste. So hybrid cars obviously will make a huge difference in that sense.